university. Previously, I was at University of Idaho and was in Kansas, Nebraska before that. I've done quite a bit of work in phosphorus fertilization, including work in forages, other crops as well. But as we are faced with this fertilizer price, I get asked this question: can I reduce or eliminate the fertilizer? And I say yes. Maybe that's a surprise, but and that's a big but. But should we? That's not always for a certain thing, because as we've already talked about, that so many factors could be a factor of that. I'm going to kind of look at that just a little bit differently. And I was asked to talk about some specific things. First of all, I just want to point out that we've conducted many phosphorus trials. And what's really interesting is that 41% of my trials have had no response to phosphorus fertilizer. So similar to what, Dr. Tarkerson was showing, there's quite a few trials that don't show, which is really hard, especially when you're doing the trial in a grower's field and the grower's looking at you like, well, why am I wasting money on fertilizer? Why am I putting phosphorus on if I didn't get any response? And that's not a good view, and I'll show you why. I would actually say if I separate those out into my forage trials, it's even more. It's more than half of them. I did not get any response to fertilizer phosphorus. So why do we even bother? I mean, what's the point? We need to take a longer view of this. We cannot look at a short-term view. We certainly have to focus on the short term. We have to look at, what are this year's commodity prices and forage prices and fertilizer prices, but we really, to kind of get an understanding of why we need fertilizer, I love to show this. And I apologize, it's in metric, but it's the principle we're looking at here. And so, for every, the y-axis is in megagrams per hectare. And so, and this is corn grain, but for every 1 megagram per hectare, that's about 15 bushels. Okay, so that's our conversion factor here. So when this is a 50-year-long trial, and I was involved in it, when I was in graduate school at Kansas State, and it's been going on a long time. So when it started, some of the plots hadn't had any fertilizer. Okay, so they really had never been fertilized, or if they had been, they hadn't been fertilized for many years. And this, what you're looking at here in the squares, the data that's represented by squares is 0 nitrogen, 0 phosphorus throughout the 50 years. So what do we see? We see a little bit of a trend downwards, but not much. It's mostly flat. I think that's important. If we stop fertilizing, we're not going to go to 0. There is natural cycling that happens out there, and who's fertilizing the forest? I mean, it's God, right? There's no fertilizer getting put down, and yet plants are growing, and because there's these natural cycles. But the problem is that they're growing at some pretty low rates, and they're not yielding, where we need them to yield in order to keep the world fed. So if we look at now, these are plots that they had been fertilized prior to 1960, and then they continued to fertilize them at the same rate, which is roughly about 200 pounds of nitrogen per acre. And then if this is in P, but if you convert it at the fertilizer phosphorus, it's about 40 pounds of P2O5 fertilizer. And so that's what it got every year. And you can see, slight upward increase over those years. And why? Because of improved hybrids and other things that improved. And so that's important. Okay, well, what if we take those plots in 1960 and we just shut them off? We stop fertilizing them. So that's kind of this group. You see this steady trend downward. It's not immediate. And that's part of what I'm trying to point out here. If we kind of look at these open circles that represent that data, that again started out as fertile, and then over time we allowed it to become depleted. Well, shoot, I mean, in 1960 the yields were sitting right up here, about 8.5, 9 megagrams, and then the next year, no phosphorus, it actually went up, and then it went down, and and it kind of bounces around, right? But the overall trend down, and we get some real, towards the end, we're getting some really low things. So this is reality. And if you look at long-term studies, this is this is what we're doing. A lot of times we're fertilizing for the future. I'm really concerned actually that I see so many, trends of folks saying, hey, stop fertilizing. That's ludicrous. We shouldn't be doing that. Now, I will say it's important to understand before we go any further is that there's a big difference between nitrogen, phosphorus, potassium, and the others, okay? Nitrogen that Dr. Tarkelson talked about is very transient in the soil. The system is more leaky. It doesn't tend to remain in the soil as long. I mean, if you stop fertilizing with nitrogen, the impacts are going to be greater sooner. But phosphorus, potassium, they're kind of stored in the soil in a bank. And we don't run out if we stop fertilizing in any one year. So my family, for example, has utilized that principle. When fertilizer prices were high, we've kind of cut back, or maybe in some cases gone to zero. And we've, maybe we have leased ground and there's no fertilizer in the agreement, and we've said, you know what, we're just gonna take some nutrients out of the soil because it can afford it. All right. So I love this. This is out of publication that we put together, and this shows the green revolution. Shortly after World War II, yields have just steadily increased. This shows a variety of crops. You can pick about any crop. I don't have any forages on here. Sorry about that, but you get the idea that it doesn't matter what crops we're looking at, their yields are going up because we're getting better in all respects. A lot of this is fertilizer availability. Some of it's pesticides, other things, but the bottom line is things are going up. Well, I would say that increasing yields have more phosphorus need. Now we just heard that there's a decoupling, and that's potentially true, but I'm thinking about it differently. I'm thinking about it in terms of removal. If I'm pulling off more crop, my soil is becoming depleted quicker. And so if we started that trial that I showed you, that 50-year trial, we started again at higher yields, it's going to become depleted over a shorter amount of time. That's my point. And I think it is important to kind of realize that what we used to do may not continue to work as we are putting more strain on the system. We're asking more. We're asking it to produce more, just like professional athletes. The high risk, high reward. I mean, we go up. We potentially are having some struggles there. Okay, let's look at switch over here and talk about these forages. If you look at how much phosphorus is just in a forage, now that's not how much fertilizer you should put on, but it is instructive. So if you look here, we're seeing values on a dry matter basis, going from about 0.26% up to 0.44%. That's pretty standard across these different types. That equates to about 12 to 20 pounds of phosphorus fertilizer per ton of material. And again, that's on a dry weight basis. So if you're hauling that off all the time, do I need to replenish it? And the answer is probably. Now we've got some soils, like for example, in Utah, we've got some soils that are just loaded in potassium, for example, that, they're from potassium feldspars blow down from the Rockies, and they're just made from potassium. And I've seen some studies, some long-term studies with just no response to potassium over many, many years. But in principle, that's not true. In principle, if we're pulling out these nutrients, we're likely going to need to replace them at some time, or we risk driving our system into the ground. I love this quote by Winston Churchill about, making sure we learn from history. You don't have to, be an expert in soil science to go back and look and see, many instances in the history of the world where the soil was ignored. They got away with it for a while, and then they got into trouble. Like the colonists, for example, came here. They'd been farming these, depleted soils in Europe for a long time, and then they get here, and these soils were just rich, and they just farmed the heck out of them. And then after a while, their tobacco crops started tanking, and other crops started tanking. So that that's something to think about. All right, this has been mentioned already. I'm not going to go through it specifically, but the 4 R's of fertilization are important. It's important to think about that in terms of phosphorus. So I was asked to talk about some of these. I'm just going to briefly mention 3 and then dive in a little more deeply on sources. I do think it's important to soil sample. I think it's important to get an accurate soil test. I also think it's important to realize that on average, we are actually depleting our soils. This is a survey of literally millions of soil samples that was done, and it's showing this trend is we're getting an increase in the number of soil samples that are testing in the deficient range. Now, that's not true everywhere, but on average, that's true. In terms of this rate, it's important that we have a correct interpretation. Looking at these studies that are done, relying on real science and not just speculation and hyperbole, we need to interpret those soil tests accurately in order to get the right rate down. Right placement's important too. Not as important maybe in most forages, but like with with corn silage, for example, I would say placement is really important. In principle, if I can get this, I can get the phosphorus into the soil, it's better. I'm a proponent of, if I'm getting ready to establish a field of alfalfa, for example, that first, being able to incorporate that phosphorus into the soil, that's relatively an important time to put that fertilizer down. Now, can I apply fertilizer to the surface and have the phosphorus being taken up by the alfalfa or pasture grasses? Yeah, but it's just not as efficient, is my point. We can also have some efficiency gained, so when fertilizer prices are high, we can potentially gain some efficiency by placing the phosphorus in a concentrated band. That more than doubles my uptake in the first year, and that can be a strategy that can be used in a year when fertilizer prices are high. Obviously, that's not true. You're not going to do that with alfalfa necessarily, but like for, again, corn silage and things that we can plant in rows. Just kind of showing this data quickly. We're looking at the percentage of the phosphorus that was applied and taken up by the plant. You can see, when we broadcast and incorporate that into the soil, in these 3 fields that I did some work on, we were between 5 and 10% was all for the first year uptake. Now that doesn't mean, I get people seeing that and they like, is that fertilizer lost? No, we have other data that we'll show here in a second, or a quote anyway. Fertigation is even less efficient. Same thing with foliars. We tend to get less uptake, not in all cases, but typically. But again, when we band apply things, so placement is important. Not as big of a deal when we're talking about forages. It's established pasture alfalfa. We're not going to be able to do much in terms of placement. And I would say that maybe the argument that a foliar would be better. I don't know that and typically I'm not seeing that in my data. Again, just a reminder, most of that fertilizer is going to be taken up, or even if I only get 10% up this year, over the next decade, it's going to be taken up with the case of the phosphorus. It's not as leaky in the system as nitrogen is, as I said. All right, so what about timing, fall versus spring, fertigation versus foliar? Those are considerations, and I don't have time to really go into them much. I want to shift gears to my final thought here is the right source, and looking at what we call enhanced efficiency fertilizers. I could talk about lots of them. I'm going to focus on just 2 that I have a lot of data on. This is a study that I published on one particular product, and I like this. It's really fascinating to me because this was a survey of 500 field sites all over the US on this particular product. And what we're seeing on the x-axis here, well, on the y-axis, you're looking at relative yield. So if it's 0, that means there was no increase. If it's above the line, it was an increase. Below the line, it's a decrease. The x-axis are soil test categories. And so if you look at this, these first categories mean that at the low soil test rates, we were on average, yield increases. There you go. I mean, we got lots of data that says that, despite some people who want to poo-poo on soil testing. We get high enough, we start seeing no response. And if we get really high, we can actually see some negatives, probably due to some imbalances. So I think that's really fascinating. But what's really important here is kind of my take-home point is that we felt like, looking at this data, that we had to reduce the rate by about half in order for us to get those responses. If I used a high rate, I actually didn't have any opportunity to enhance the fertilizer. Enough phosphorus is enough. I don't necessarily need more. And so if I'm using one of these enhanced products, I probably should be cutting my rate. Enhanced efficiency doesn't necessarily add further yield increases. And in fact, like I said, it could even reduce the yields. So here's another one too. Let me just show this one. So this particular product, I've done a lot of work on. It's an organic acid, and I've worked on this one and several others. I spent a lot of time researching these organic acids and how they affect phosphorus solubility. And what you're looking at here is that the percent increase in solubility of the phosphorus over traditional fertilizers. The gray bar is MAP, and the black bar is 1034O ammonium polyphosphate. And you can see that having that organic acid greatly increased the solubility, which is particularly important with crops that are permanent crops that we don't have the opportunity to inject the phosphorus into the ground. But by adding this product, I can actually move the phosphorus because it's more soluble. It doesn't just sit on the surface, and it moves down. And so you can see that in this next graph. You can see this is comparing liquid 1034O in the black, and we put it on, and it basically just sat there in the top 6 inches. Whereas with this product with the organic acids, I was actually moving it down into the 2nd foot, making significant increases in the phosphorus down where those roots are. So that's potentially, if you have a product that can do that and has proof of concept and proof that it actually works in the field, that's something. And there are some out there, and I don't have time to talk about it all tonight, but there are some out there that will do this. And then this slide just kind of again shows that same thing that I said with the first product, is that with these organic acids, we actually found that we had to reduce the rate in order to get the benefit. And these things typically cost more. And so not only is your regular phosphorus product going up in price, these are going up in price too. And so is it worth it? That's the big question. A lot of these things are priced so high, no, they're absolutely not worth it. But if it's if it costs me 10% more, but I can put on half as much, you know what? There's an opportunity. It's an opportunity for me to cut my rate by using an enhanced efficiency product. But if it costs 3 times as much and I'm reducing my rate in half, I'm probably not money ahead to use an enhanced efficiency product. So in conclusion, we need fertilizer. I just can't say that strongly enough. In a world that seems crazy to me right now, where I have people running around saying we don't need fertilizer anymore, I just really disagree strongly. We can cut back, and again, sometimes some situations I would recommend it. I got a high soil test phosphorus, I'm definitely cutting back and maybe applying 0. So yeah, there are opportunities. We should not be complicit again in this long-term destruction of soil fertility. We've built these soils. We need soil fertility. It's important not to deplete them. It's important to apply the correct rate based on soil test and good science, with optimized timing, placement, and source. And then here in bold, these enhanced efficiency phosphorus fertilizers, they generally are only proving beneficial at low soil test phosphorus and at reduced rates, and also at a reasonable cost. But there are some opportunities there potentially, depending on cost. So with that, I am